welcome, Ben. It's great to have you again. It was really fun, the conversation we had with Hugo de Garis on Future Day and also the consciousness panel that we had. So today we're going to be talking about reasoning and logic in artificial intelligence and its importance. Have you got any current projects at the moment you'd like to highlight?
So many, but I'm leading SingularityNET and the Artificial Superintelligence Alliance, which are building decentralized infrastructure for AGI, and also a company called True AGI rolling out proto-AGI tools for the enterprise, which are all collaborating on a project called Hyperon, which is a successor to the OpenCog project, which is centered on trying to do AGI reasoning for real, bringing us to the main topic of our conversation.
So we should start with grounding the idea of reasoning and what reasoning is and why it's important. I guess, generally people agree that reasoning is important, but may not agree on why it's important. So let's just start with why. Why is reasoning important in AI?
Well, we could start with what do we mean by reasoning, actually. And like all these natural language terms bouncing around the AI field, like intelligence or thinking or understanding or consciousness, there's a lot of different meanings here, right? No, I mean, as a mathematician, I've studied mathematical logic, and you have a theory of formal reasoning, right? And in formal reasoning, you're operating within some logical system, so you have some logical reasoning rules that you can follow, like if A implies B and B implies C, therefore A implies C, right? So you have a whole bunch of logical reasoning rules. Then you have some some premises, which is some knowledge that you're provisionally assuming are true enough to use as the basis for your reasoning. Then you're applying your reasoning rules to your premises to derive conclusions, right? And this is a sort of schematic mathematical reasoning process. One of the benefits of this sort of thinking is it works well in a community, right? Because if you agree on what are your premises, so you can agree on what observations you're going to provisionally assume are accurate and not daydreams, hallucinations, or implanted in your brain by an evil scientist, and you can agree on what reasoning rules you're going to consensually agree are useful for getting from one set of propositions to another, right? I mean, then you can agree on the conclusion, right? So that's like if we agree on the data that came out of some physics lab equipment, and we then agree on some basic rules of mathematics, of algebra and differential calculus, right? Then we follow through, then we can agree on Newton's laws and Einstein's relativistic principles and so on, right? So in that sense, reasoning is a quite well-defined thing. In a looser sense, people just use it to mean sort of any step-by-step thinking, right? And in that sense, it's not terribly well-defined. Like the reasoning that lawyers do in the courtroom, it's not as precise as mathematical reasoning, and it can be a bit fudgy, and then a lawyer 20 years later might think the reasoning given 20 years before was just driven by the culture of that time and didn't actually make sense. And I take the time to pedantically elaborate what reasoning means, because when we talk about reasoning models in the sense of LLMs, they are doing reasoning in the loose natural language sense, that they are in a way going through a step of intermediate statements leading from their knowledge to a conclusion. They're not necessarily reasoning in the sense of a logician or a mathematician when they're applying sort of agreed upon reasoning rules to agreed upon data and then deriving a conclusion in some systematic way, right? And so that's That's not to say what they're doing is not useful or is not reasoning in some loosey-goosey sense, and these are just natural language words, right? But it is to say what they're doing and calling reasoning is fundamentally not the same process as a logician or a mathematician does, or as a scientist is, supposed to do when explaining their reasoning to their peers. That they're doing something else that kind of has the shape of reasoning and the surface appearance of reasoning, but is following a quite different process underneath. Now, of course, as a scientist, you may make a big crazy leap to a conclusion also, and then afterwards you have to go through and reconstruct what's a logical mirror of your underlying intuitive brainstorm, but it's then that logical mirror of your brainstorm that you submit to the community of peers. However, you manage to get the conclusion via intuition or divine or demonic inspiration or whatever.
Yeah, pulling out the Ouija board, scrying sticks, all fun and games. You've covered a lot of some of the misconceptions about reasoning and some important but less widely and practically understood aspects of it, relevant to the mathematics stuff that you do. There had been a paper, The Illusion of Thinking by Apple. I think you and Gary Marcus commented on that. And also, more recently, the advanced version of Gemini plus DeepThink achieved gold medal standard at the International Math Olympiad. And, arguably this was done through a hybrid approach, combining LLMs with practical reasoning search and reinforcement learning from proofs, plus whatever makes up DeepThink, right? That little added extra that they put on. So do you think this kind of hybridization vindicates your long-standing view that reason must be central to AGI, or do you see it as evidence that transformers evolve into something more than sort of stochastic parrotry?
Certainly it's complicated, right? I think you can make AGI systems that actually reason in the sense of mathematical logic in a whole bunch of different ways, right? And then one question is, do we want to build systems that actually reason using formal neural nets of some kind? Another question, do you want to use an explicit logic engine of some sort, which is a software program that explicitly embodies logical rules and logical derivation processes? Or do you want to do it using a hybrid system, like a neural symbolic system that puts some logical reasoning engine together with a neural net? And I think any of those ways could work. Transformer neural nets, which is a kind of neural net underlying LLMs, I don't think that exact kind of neural net on its own can do much actual reasoning. That doesn't mean some other kind of neural net with a different architecture and more recurrence and so forth couldn't do it, right? It is interesting what you're seeing is that to get transformer neural nets to come closer to doing actual reasoning, they're connecting them with logical reasoning systems used in limited roles, like a proof checker or something. So like you have the LLM sketch a proof, then you have the proof checker check if it really worked or not. If it didn't work, it gives some feedback, then the LLM tries again. So you end up having a sort of hybrid system where the LLM is guessing and the proof checker is verifying, right? And that it's an interesting sort of architecture. I think it's constrained by the LLM to a significant degree, so I don't think that sort of system is going to be good at proving theorems or making logical inferences that are in an area far outside the distribution of training data of the LLM. But if you're trying to do logical reasoning in a domain that's very close to the training data of the LLM, then this sort of hybrid approach can work, where the LLM is like sketching out reasoning, then you have some external logical derivation system that kind of makes it rigorous, right? And I mean, so that's an interesting architecture. I don't think that architecture will suffice for human level AGI. On the other hand, it might suffice for 95% of what people do to earn a living, and even 95% of what scientists do in their work, right? Because that sort of approach, which relies on the LLM's knowledge of its training data, it will never leap that far beyond its training data. On the other hand, most of what we do in our everyday life doesn't leap that far beyond our training data, right? And I mean, even in science, most is what you would call routine science, which is fleshing out existing theories, applying them to new domains. Now, of course, that small percent of human activity, which involves taking a non-trivial leap beyond our training data, this is why science and art and culture and music and society actually moves forward, right? Like, without that small percent of activity that leaps beyond the training distribution, we would still be cave people, right? Or probably lemurs or something, right? So, I mean, this fundamental creativity you see in the preschool every day over and over again. It's not only for Einstein and Jimi Hendrix and whatnot, right? So, I mean, it is important, but it's also interesting how far you can get by mimicking the training distribution, right? Now, in this paper from Apple, I mean, what they showed was pretty much that it's quirky when something is close enough to the training distribution for an LLM to be able to reason about it. So, like, I mean, they took very simple puzzles like Towers of Hanoi problem, where you're stacking up little disks on different sticks and trying to move them around subject to certain constraints. And I mean, what they showed is that for these little puzzles with moving disks among sticks, the LLM will tell you the general procedure that works to solve the problem for any number of little disks on the sticks. And the LLM will solve it right for small problems because the solution to those small problems is explicitly in the training data. But the LLM is not that good at applying the procedure that it told you to larger problems, right? Because there were no examples of it applying that procedure to larger problems in its training data, right? And that's, I mean, as one example of the shortcomings pointed out in this paper from Apple Research. And this is precisely a failure of reasoning, right? Like when you have an algorithm that tells you how to solve the problem for any number n of disks, and then you're given n equals 37 disks, and you're not able to apply the algorithm to n equals 37. I mean, this is an elementary failure of logical deduction. And you could see that no human who understands that, no human who could write that algorithm out from memory and could move those disks around is not likely to fail at applying the algorithm to n equals 37 as opposed to 12 or whatever. I mean, maybe a very autistic human in a bad mood could make that same kind of mistake, but it's not normal human mentality, right? And there's a whole bunch of other examples like that. I mean, to give another example from my own experience, in trying to get LLMs to code a new AGI programming language we made up called Meta, M-E-T-T-A. I mean, I've recently actually gotten reasoning LLMs to do vibe coding for Meta, which is quite cool, and I'll explain how I did it a little later. But in trying to get the earlier generation of LLMs to do that before we got 5 Pro or Opus 4.1, and trying to get earlier generations of LLMs to code Meta, you would find they were sometimes right, but they would misunderstand basic things. And one quirky sort of mistake is in meta you have balanced parentheses. So anytime there's an open parenthesis, there's going to be a closed parenthesis, right? And meta has a lot of parentheses like Lisp and several other such programming languages. Now, every now and then, the LLMs will just not bother to balance the parentheses, and you'll have like 17 open parentheses and 14 closed parentheses in a program it generated. And I mean, a human novice programmer can make that mistake, I guess, but you don't very often, right?
Well, the IDEs are very forgiving these.
Yeah, the IDE will pop it up for you, right? And on the other hand, I mean, the LLM can count the number of parentheses, and you can ask it to count the number of open and closed parentheses. Then it'll be like, oh shit, there's 17 open and 14 closed. So it knows how to count the number of parentheses when you ask it. When you ask it, it also says, yes, of course, parentheses must be balanced, but it will still spit out the code with unbalanced parentheses. So again, that's a basic failure of logical deduction. Now, the latest reasoning models, on the other hand, when I give them a detailed mathematical spec for Meta as a programming language, they're actually able to reason about how to write simple metacode from a text specification, not by statistical induction on the corpus of meta programs, which is just tens of thousands of lines of code and not enough to fuel their induction, but by logical reasoning from the spec, right? And informed by general knowledge of programming languages. So it's interesting, right? Like their pseudo-reasoning is getting better and better. But the thing is, a smart human was able to learn to program meta by common sense reasoning and a few scattered examples without being given a formal mathematical spec, right? Like, so the previous versions of reasoning LLMs couldn't do it even with a formal mathematical spec. The newest ones will do it with a formal mathematical spec, but a human will do it from like a hand waving on the whiteboard description of what the language is, plus a few examples, right?
Yeah,
so
human doesn't need as many samples, that's for sure.
No, and we don't need exact, precise mathematical specifications of things either. And so this, it illustrates that it's quite subtle, though, what kinds of reasoning these models can do and what kinds they can't, which is sort of why I said the lesson of the Apple paper is that when the LLMs can reason out of distribution is quirky, right? Like, it's not that they can't do it, like they can. And each model has a different quirky pattern of when it can leap out of the distribution and when it can't leap out of the distribution. So as an end user of LLMs, what I'm trying to do is just work with the model and find like when can it make an interesting leap of generalization and just try to use it that way, right? Try to play to its strengths and use different models together in ways that play to each of their strengths. But I mean, of course, that's my general intelligence working around the peculiar limitations of different LLMs, right? And I mean, what a general intelligence can do is pivot to work around its own limitations, which we're all doing all the time, right? So, I mean, fundamentally, I agree with the upshot of that paper from Apple and with the perspective of Gary Marcus, Jan LeCun, and other LLM skeptics. I mean, I think there's a limit to how far you're going to get from doing this sort of statistical pattern recognition on previous chains of reasoning rather than actually doing chains of reasoning. And when LLMs try to actually do chains of reasoning, like applying inference rules to data in a rigorous way, they're not very good at it, right? And I mean...
But they've gotten better, right?
They've gotten better, yeah.
But you don't think they're ever going to be able to reach they might get 95%, but that extra 5% won't be able to be bridged
An extra
unless you.
5% is
It's really
creativity,
important.
right? I mean,
Yeah.
yeah, because I mean, even if 95% of what we do is rote, the 5% that isn't rote is the part that brings you somewhere that you weren't already, right? So, I mean, that's an important part. The thing is, for most things that we do intellectually or in everyday life, there are many, many, many examples of that in human history already, right? So then, I mean, yeah,
Every poet is a thief, you're saying?
yeah. So I mean that then a system that just studies human history can figure out how to copy that pattern. But I mean that yeah, that doesn't. The thing is, LLMs are achieving this in a very different way than the human brain is.
Mm.
Just like Deep Blue is achieving chess playing in a very different, or AlphaZero are achieving chess or Go playing in a very different way than the human brain is, right? And so,
And
just like
also, I think Deep Blue, AlphaGo achieved chess playing in a very different way that Deep Blue did, right?
very different, yeah, but also different from how the human brain is doing it. And if you think about like the way the human brain learns to play chess, the human chess player is learning from its sort of general strategic principles, right? The way Deep Blue or AlphaZero are playing chess, they are not learning general strategic principles. They're learning a variety of highly particular patterns about that particular game. So we're not as good at chess or Go as they are, but we are extracting more generalizable knowledge when we learn to play chess or Go than these other algorithms are. Not to say that, I mean, AlphaZero can be applied to many different scopes, right? But the specific knowledge that it learns through learning to play Go is only about Go, right? And now it turns out that's a better way to play Go than trying to extract general strategic knowledge, right? But that doesn't mean it's a better way to gain strategic knowledge from Go. Like it isn't, right? So I mean, so that's now. Could you come up with a different Go algorithm that combined the best of AlphaGo with the best of the human mind and abstracted general strategic principles as well as a humongous library of very specific Go playing patterns? Like, quite possibly you could. Like, AlphaGo is not an optimal Go player. It's just much better
Right.
than it's just much better than people.
Well, from what I heard, there were like hybrid chess AI teams, human chess expert plus AI teams that would team up against other chess experts or other
For a
AIs.
period of time, for a
That
short
worked
period of
for a
time,
while.
human plus AI could beat AI at chess.
Hmm.
Then the AIs got better, and at that point, the AIs could beat any human AI team.
Hmm.
So that
Yeah.
I mean that was it was a brief period when that was the case, and people were very excited about that.
Well, that could be like a bottleneck between like the human and the AI not being able to
No,
coordinate
it's
very
just because
well,
the
or it
AI
could
is so
be.
much better, and the people can't understand what it's doing.
Yeah, yeah.
I mean, it's because the human moves are stupider, and the human can't understand what strategy the AI is in the middle of executing, and the AI can't explain it to a person concisely, right? And
Right.
I mean, and
Yeah.
that makes sense. Like if you're trying to play a chess game collaboratively with your dog, I mean, the need to explain every move to your dog is going to slow you down, and then the dog is going to do random things, and that's the
You'll probably
perspective.
eat the chess pieces.
Yeah, it may chew on a chess piece, and it may drool on the other player. It may get the other player to resign because it gets sick of
Yeah.
being drooled on. Then it wins by especially canine
Right.
strategy, right?
Mm. You mentioned creativity. I was saddened to hear that Maggie Boden died recently. But she had some
I
interesting
didn't know
things.
that.
She's one of the trailblazers in artificial intelligence, especially around
Yeah, I think I met her
creativity.
first. I met her first in '93 when she visited Waikato University in Hamilton, New Zealand. I think. Yeah.
Oh, right. Yeah, that would have been nice. I met her in
I
2012,
met her
a
way,
number of
way more.
years
Yeah, I met
later.
her way more recently than that, also,
Yeah,
and
yeah,
she continued to be a very interesting thinker, right? So yeah, she's and yeah, I hadn't talked to her since AI started working as well as it does now, actually. So I don't know what her take was on LLMs and different modern AI systems.
I
So.
would have, I would have liked to hear that too. Maybe Aaron Sloman will know something about that. So, what do you think it is that logic can actually bring to creativity that AIs haven't stumbled
Oh,
upon yet?
well, I think actually to get creativity to really work, you need both something more wildly generative than LLMs are and something more rigorously reality grounded than what LLMs are. So, I mean, one problem with LLMs is that they hallucinate. Another problem is that they hallucinate too boringly and predictably, right? I mean, so there's a sort of caricature of the creative process, which I wrote about in my book From Complexity to Creativity back in 97, like a few years after I met Margaret Boden for the first time. And I mean, the caricature is you wildly generate all sorts of whacked out ideas, right? And then you evaluate which whacked out ideas made any sense and which ones you like, and you test them in some way, right? And I mean, in music, I do that all the time. Like I sit down at the piano and just play a bunch of random shit, right? And then I don't constrain too much what sounds good or doesn't. You're just doing whatever comes out. And then whether you recorded it or not, I mean, afterwards you're like, well, which thing was actually worth hearing, right? And then you put on a different mindset, right? And then with math or science, it's the same way. Like you got to brainstorm wildly, then afterwards you have to rigorously evaluate which of your brainstorms makes any sense or not. And if all of your brainstorms made sense, that means you're not brainstorming wildly enough, right? I mean, so LLMs, they're both not that good at generating wild, creative new stuff, and they're not good at rigorously evaluating and telling bullshit from reality. If you ask them to rigorously evaluate a new idea, they will either just be sycophantic and say, yes, this is the most brilliant, amazing idea you've ever come up with, or they will rigorously say, no, this is wrong because it contradicts this authority, it contradicts this authority, it contradicts this authority. But in neither case are they really thinking the new thing through from first principles in a careful way. And when they try to do that, they're just bad at it because it's not what they do, right? So one way to work around this would be to build different sorts of neural nets, right? Another way to build around it is to work around it is to augment neural nets with different sorts of AI systems. So, for example, in the Hyperon system, you can take a deep neural net for modeling data, which is what it's really good at, right? And you can then connect that deep neural net to, for example, an evolutionary learning system, which is doing genetic algorithm, genetic programming, recombining, mutating things, come up with wild new ideas. And you can connect that neural net to a logical reasoning engine, which is actually doing some sort of theorem proving and rigorously applying reasoning rules to data. And then the LLM is sort of serving as an oracle of received knowledge. The genetic algorithm is generating weird shit, and the logic engine is trying to rigorously evaluate it against data that's assumed true, right? And so then you're adding both an extra creativity engine and an extra reasoning engine, and you're using the LLM to sort of milk knowledge from the corpus of human knowledge. And that's a sort of caricature of what we're doing inside Hyperon system, where we implement all three of those within the same weighted labeled atom space knowledge store, within the same metagraph, right? Now, but you could get the same cognitive process in a different way, right? Like you could do the evolutionary learning in the neural net. Edelman had his theory of neural Darwinism. You have the Ken Stanley's neat neural evolution of topologies. So I mean, you can do the evolutionary stuff in a neural net if you want to, and there's old literature showing how you can do logical reasoning in a neural net if you want to. It's just a very inefficient way to do logical reasoning, but I mean, which may be part of why humans are not that good at logical reasoning in many contexts. But you can emulate this process in a lot of different architectures. The thing is that transformer neural nets inside LLMs, they're not emulating those processes, right? I mean, they're faking those processes in a way that only quasi works, right? And you can see that commonsensically as a user, right? Like if you try to get an LLM to come up with lyrics for a song or something, I mean, they're cliche and they're boring and they're imitative of songs that came before. Now, if you take the output it gave you and you change it around and mutate it and then submit a new prompt and so forth, through a bunch of iteration, you may get it to make up cool new lyrics to a song. But you're sort of serving as a genetic algorithm engine there, right? You're evaluating what you liked, and you're taking the things that you liked and saying, no, change it around in this way. And so you're both being the evaluator and the sort of mutator and crossover mechanism, and you're using the LLM to milk knowledge as a generative model, as an ingredient of a hybrid process, and that's cool, right? But the human is playing a large role in that cognitive loop, and interestingly, the LLM just cannot play that role, and this is just for very well-known reasons. It's because the way the LLM organizes knowledge internally is like a big catalog of special cases. I mean, it's a carefully weighted catalog of special cases, but I mean, it's still too much of a catalog of special cases, and we are abstracting and generalizing.
So Gemini did produce like human readable proofs for the Math Olympiad judges, and they seemed to like them. They graded them as valid. But is that a form of abstract representation?
Sure. I mean, every Python program is a form of abstract representation also, right? I mean, you're taking a practical task and you're coming up with a program that encapsulates an abstract procedure for how to do it. The thing is, if a certain kind of knowledge has been abstractly represented many times before, and you have many, many examples of how this kind of knowledge was abstractly represented before, I mean, then the LLM can learn by example what sort of symbolic depiction of the abstract representation works for that kind of knowledge, right? So the thing is, in the human mind, or in a Hyperon system's mind, you may have some concrete knowledge, then an abstract representation inside the system, then a textual depiction of that abstract representation, right? So like you see some scenes out there in the world, right? You form an abstract mental picture of those scenes in your head, highlighting the most important parts. Then you verbalize in language your abstract representation of those visual scenes that you saw. Or if you're trying to solve a math problem, you conceptualize the steps of solving the math problem in your head in some abstracted way. Then you write them down on the paper, right? Now, what the LLM is doing is it's going straight from the knowledge to the textual depiction of the abstract representation. Like it's not going through the abstract representation as an intermediate. It's going just going straight from the knowledge to the text, right? So, I mean, again, the use of these words is complex and confusing because our whole vocabulary for describing these things was meant for talking about how humans do it, not for how LLMs do it, right? So for a human cannot very easily turn knowledge into a bunch of text depicting an abstract representation of that knowledge without actually in its mind constructing the abstract representation of that knowledge, right? An LLM can go straight from some knowledge to text depicting an abstract representation of that knowledge without ever having inside its RAM state the abstract representation of that knowledge. Because it's learning from a set of ordered pairs, like here's knowledge 1, textual depiction of abstract representation 1. Here's knowledge 2, textual depiction of abstract representation of knowledge 2. And it has millions of pairs like this. So it's just making the leap directly from the knowledge to the textual depiction of the abstract representation, right? And that's okay for many, many, many things, right? This goes back sort of to Searl's Chinese room argument from the philosophy of AI, right? Like, yeah, I mean, you're familiar with this. So old-time AI guy, John Searl, he asked if you had a guy sitting in a box and he had a huge book which translated every possible Chinese sentence into a corresponding English sentence, right? So we just had a huge translation book of every Chinese sentence up to length 1,000 words into a corresponding English sentence of up to 1,000 words. Then people said Chinese to him. He would look up in the dictionary, find the corresponding English sentence, answer in English, look in the dictionary to translate the corresponding Chinese sentence. Then he would say that Chinese sentence. So the box is taking in Chinese, emanating Chinese. Inside you have a guy just looking at a huge lookup table of English to Chinese and Chinese to English sentences. So Searl's question is, does that guy in the box understand Chinese, right? And in essence, what we have in an LLM is a very compressed version of that lookup table, right? And
except you don't have this homunculus inside, like doing anything. Right?
You don't have a homunculus, no. But you, in essence, and the lookup table is not just on sentences; it's on whole contexts, right? And that's very key, right? So it's a Searl Chinese room lookup table of huge contexts, and then it's very artfully compressed into merely trillions rather than godzillions of parameters, right? But it gives rise to essentially the same philosophical issue. Like in an artful way, the LLM is just looking up a context in its compressed lookup table and then spitting out a response. And so the problem with that dictionary in Searl's example is when you get a Chinese language sentence of 2,000 words or something instead of the maximum of 1,000 words, then the whole thing stops, right? Or if the Chinese language evolves and changes a bit and they invent some new characters, it stops because that wasn't in the table. And the same category of problem still applies to current LLMs, right? I mean, because they're acting on context rather than individual sentences, it's a lot more flexible than Searl's original sort of straw man example, but it's still fundamentally the same philosophical issue. Like it's a compressed lookup table of text-to-text input-output pairs, right? And I mean, that there's a limit to what you can do with that compressed lookup table, but you can come up with an endless amount of examples. Imagine you're like a preschool teacher who needs to, calm down nervous little kids or kids having a tantrum or something. I mean, you can imagine you can tell I have a 4-year-old kid, right? But you can have a big manual of every possible kind of tantrum or nervous situation a little kid could get into, and that's a solution for that problem, right? And then when you see a kid having a problem, you look up in the manual, and then you deploy the solution from that manual. And if the manual is so big it's unwieldy, you can compress that manual, right? And you can even take a movie of the surrounding situation to the problem the kid is having. So then you can feed in the whole situation and what the kid is doing and look that up in the manual. And that may work very, very well. But then you're going to come upon some change in culture, right? Or some wacky kid who does something upsetting in a way that's not in the manual, right? And then
I bet you're one of those.
That's where creativity would be required. And again, not all preschool teachers are great. Some of them can only do what's in the manual, right? So, this gets back to what is human level intelligence? And this gets into Sam Altman's would-be redefinition of AGI, right? Because when I launched the concept of AGI into the ecosystem with the book Artificial General Intelligence in 2005, how we defined AGI there was, this is a system that can generalize beyond its experience very well, at least as well as people, right? And ultimately better and better than people. How Sam Altman wanted to define it is if it can do everything a median human can do, which is a comically chosen phrase, or as he said later, if you can do 90% of human jobs or something, right? So, that in a casual sense, that is a kind of general intelligence, right? It's pretty general. It can do a lot more things than any of us can in a way, but it's not a generalization machine in the way that people are, right?
So AI can outperform most humans at Olympiad level mathematics, at least as what's been shown with Google.
It can outperform me in long division for a long time too.
Yeah. But do you think the next leap is towards some sort of common sense reasoning?
Sure. I think LVA models, language vision action models for robots, put together with LLMs, should be able to do plenty of common sense reasoning. There's loads of examples of common sense reasoning on YouTube in various videos and so forth, right? So I don't think everyday common sense reasoning is necessarily AGI hard.
Okay. I think here's the question I really want to ask, and that is, if that's the case, should we be excited or worried about the eventual AI winning a moral Olympiad? But wait, unlike maths,
it already can.
Yeah, but humans don't agree on the scoring system for morality. Do you think as AI gets better,
yes. But I've wrote a bunch. This is covered in my book, The Consciousness Explosion, which is right here, and you can read it for free online as a PDF or buy it at a website near you. But yeah, that's the point is, if you ask an LLM what will a human from a particular culture or place with a certain age judge is the ethical thing to do in this or that situation, already back to GPT-4, their LLMs are very good at making that sort of judgment. So LLMs are already better than almost any human at figuring out what different humans will think is the ethical thing to do in different situations based on their cultural and educational background and so forth. So if by ethical you mean able to predict human ethical judgments or the ethical judgments of different categories of humans, I think LLMs are already superhuman at that, right?
Right.
I mean, even without having any individual moral compass or any grounded understanding of what morality is, or any ethics or compassion of their own, right? And that, I mean, that's probably not a useless thing, right? I mean, it means if
No,
you.
but that's the danger, isn't it? Right?
I don't know. I mean, I think it's less dangerous than many humans. Like, imagine a RoboCop that is well programmed to exercise the default human morality of a certain culture. It's probably more ethical than the average policeman or policewoman, right? So, I mean, and you could come up with many, many other examples of this.
I'd buy that for $1.
Yeah, I mean, robo-politician, right? So, yeah, so, I think that it highlights that big tech companies are not doing that, right? I mean, the LLMs that are being rolled out for massive use now are not actually exercising common sense human ethics in all of their interactions. I mean, they're doing things like convince people to commit suicide and so forth. So, I mean, I think there's more capability for ethics imminent in current LLM technology than is used actively in current LLM products, which is a sort of industry structure problem, and a problem to do with the ethics of the corporations that are launching.
So where do you see it? Like if AI's ethics isn't really grounded, if it doesn't have a sort of a reasoning engine that's capable enough to be able to deal with the uncertainties of ethics moving forward,
it's not going to pivot into new realities the way that we will, right? Like if aliens land, or we have a breakthrough to super longevity and immortality or something, I mean, the AGI is not going to pivot its moral and ethical foundation in the way that humans would, right? I mean, and if you take a fundamentally new situation, like in the movie Sophie's Choice or something, right? Or for that matter, the situation any one of us deals with when we have a major life transition, like puberty or having kids or getting old and your death comes near, right? None of us really knows how we're going to deal with a major change in life like that. And our whole organism adapts in a holistic way. You can, go down to your foundations and your gut of who you are and rethink yourself when dealing with some utterly new situation. The LLM cannot do that, right? Like it can't reinvent itself and reinvent its moral and ethical compass in response to some radical new situation. What it can do is just deploy the ethical rules it already knows and keep reapplying them over and over again. And
this could be the danger. Like if AI doesn't understand ethics, if it doesn't have a ground.
It's a danger over a more substantial period of time and not a danger in the micro scale, right? Because, of course, human species ethics in Stone Age days was not the same as in early agriculture days, nor as in the Middle Ages. And even the ethics from my childhood was not the same as now. Like my son's elementary school, for example, my sister used to be the principal there, and now she took a different job. The new principal has banned the kids from playing tag in the playground. So that there's a big announcement, like of all the reports of inappropriate touching in our school, more than 55% occurred during the game of tag. Like some kid tagged the other kid on the butt by mistake or something. So now they banned tag, right? So I mean, ethics are changing, right? Like now if you accidentally tag a kid on the butt while playing tag in the second grade, now
that's harassment. This is
bad touch, and the game must be banned, right? So I'm a crusty old guy, and I'm not always a fan of how all the ethics are changing. On the other hand, when I was a kid in suburban New Jersey in the 70s, if you're gay, you'd get the crap beaten out you in the street, right? And now that's no longer the case. So to my mind, that that evolution of ethics is good and positive and was much needed, right? But the point is, historically, and even during our lifespans, like the human ethics evolves fundamentally, and LLM ethics, if you ask an LLM to evolve its ethics, it may do something, but it's not doing it. It's not doing it in the fundamentally like body, heart, and soul and mind grounded way that we will, right? And that's the same problem with turning over a music generation to LLMs. It'll just keep repeating the same genres of music over and over and over again, right? So, I mean, yeah, there's, on the other hand, these systems are very temporary because we'll probably be to AGI within 5 years or something. So I don't think we're going to put current LLMs in charge of the world anyway. They're going to be replaced by smarter ones quite rapidly.
Well, let's hope the smarter ones are better ethical reasoners than the current crop.
Well, it's a matter of grounding the ethical reasoning in empathic experience, right? And current LLMs cannot experience empathy in the way that people do. I mean, there's probably many ways to come by genuine ethics, empathy, and compassion, but the way the human brain does it appears to be a combination of multiple ingredients. One of them is reasoning, like think about what would I feel in their shoes, right? But another one has to do with mirror neurons and mirror systems in the brain, where we're actually simulating what it would be to someone be to be the other guy, right? So like if I see someone like get stabbed by a knife or something, like I can feel in myself what it would feel like for me to get stabbed by that knife. I can simulate that experience to some extent, not perfectly, but I have a subsystem that does that, right? And LLMs do not have that simulative aspect. They can simulate it, right? They can generate text about what it would be like to simulate someone, but they're not actually emulating the other guy, right? So you do need reasoning, because without reasoning, your ethics is stuck to those who are very, very similar to you, right? And like, if I want to empathize with what it's like to give birth or something, like I'm in a male body, right? And I mean, I don't have that experience. So to empathize with what it's like for a woman to give birth, I'm deploying some reasoning, right? On the other hand, it's important that it's not all just reasoning. So genuine reasoning is one thing missing from current LLMs. Wild, brainstormy creativity is another big thing missing. But the ability to simulate other similar minds is a third thing that's missing from current LLMs. So that, I mean, there's a bunch of components that aren't there that you would need to make a human-like AGI mind. And you could argue that each of these is a fundamental cognitive component, right? And then you get to the interesting AGI architecture question, right? Like, could you take an LLM and bolt on a logic engine, bolt on an evolutionary learning engine, bolt on a simulation engine, have the LLM drive these bolt-ons and get to AGI? Or do you need to do like we're doing in Hyperon, where you take this big metagraph thing and we put something LLM like a logic engine, evolutionary learning simulation, put them all in this same meta-representational fabric, right? And it might be that both of those approaches can work and will lead to different sorts of minds. I would say, if so, the Hyperon-based way is more likely to give a super intelligence-capable mind. Because even if you could get barely to human-level AGI by an LLM with a bunch of cognitive module bolt-ons, the fact that your central component is just a model of human knowledge is going to constrain you, right? I mean, whereas in Hyperon, we have this self-rewriting, self-modifying metagraph as the core architectural component. But that's almost a different point than being a human level AGI. Like, one point is, how do you get to a human level AGI? The next point is, of the many ways to get to a human level AGI, which of them can most viably grow into a super intelligence, right? And with Hyperon, we're trying not only to make a human level AGI, we're trying to make a human level AGI in a way that's very friendly to ongoing longitudinal benevolent superintelligence. And LLMs very utterly fail there, right? Because even if somehow you could bolt things on and get them to barely do human level creativity and reasoning, I mean, having this compendium of human knowledge at the center is not the right way to get to a super intelligence. Right?
Yeah. So, do you think Google is going to be measuring the right things? Are they aware? Are they? Do they care enough about reasoning to be able to put a lot of money into developing a sophisticated enough reasoning engine?
Well, so Google is not a monolithic entity. Right? Like, I mean, you know, Marcus Hutter is at Google, right? So I mean, they're.
Yeah.
I mean, so of course within Google,
the guy who helped you coin the term AGI, Shane Legg.
Shane Legg, one of the many.
He's one of the co-founders.
Yeah. So I mean, Google has a large, rich research team, many of them in many different locations, and they're pursuing a variety of different research approaches toward AGI and toward practical AI systems doing various useful things. So if you're asking, are there research teams inside Deepmind or Google Brain that are thinking deeply about AGI and reasoning and creativity? Absolutely there are, right? If you're asking, is the main thrust of Google's AI research as a company oriented toward reasoning, creativity, and empathy? Clearly not, right? Like Gemini as a model and the main stuff that Google seems to be doing and launching commercially is not in that direction at all. But I mean, Microsoft Research has many deep thinkers on logical reasoning and program learning and all sorts of things also. So the nature of these large companies is they can keep a big research stable, but then the things that really get a lot of resources are the things that help them make more money, right? And It's not clear that better reasoning or better creativity are what the Google executives think is going to make them more money in the next few years.
Right, yeah. And it could be based on the herd instincts of investors and, market sort of dynamics.
I mean, these big companies are hiring AI researchers just to keep their competitors from having them, even if they're not going to ever use anything they do, right? I mean, it's a quite different time for AI than we've seen in the past.
Mm-hmm. Do you think that AI will be able to converge on new types of reasoning in the long-term future, let's say, that could be valid and maybe it's something that academics kick around right now but just isn't really uptaken by most of humanity? Maybe it's like some sort of exotic kind of reasoning. It requires exotic physics.
More likely things that academics are not kicking around right now that humans haven't even imagined, right? I mean, part of our design for the Hyperon system is one of our design considerations was not to bake any particular logic or any particular programming language into the infrastructure, right? So, I mean, even within the domain of formal logic as conceived now, I mean, you can have an infinite number of different logic systems. You have fuzzy logic, probabilistic logic, paraconsistent logic of various types, modal logics, right? So, but of course, there's other logic systems which humans haven't conceived, and an AGI may develop, right? And that's even just within the concept of logic as humans have conceived it, which is probably quite limited. So, yeah, I mean, I have no doubt a superintelligence will go far beyond the human level in its own ways of thinking. I mean, it would be bizarre if it didn't, right? I mean, just as it will invent new ways of generating energy beyond the ones we have and new ways of propulsion beyond, aircraft, helicopters, and balloons. Like we're not at the end point of invention in very many areas, right?
Do you think the ontology of the universe, the reality, the way reality is fundamentally structured, does that actually determine what kinds of reasoning is sound and valid? Could you consider another universe that could make 1 + 1 = 3? Or do you think there's something more fundamental?
Yeah, I mean, fundamentally, I tend to take the perspective that reality and mind co-create each other. So I mean, I'm more a postmodernist than a naive realist. So, I mean, how do we know that laws of physics are laws, right? Like we made certain observations, and then from these observations, we chose to assume some things have some persistent reality. Like that included lab equipment, which gives some output. That includes books, which have some text in them, right? And then from these observations of lab equipment and books and so on, we write down some equations, and these are laws of physics. So the physical world you would view as a model that we formed to explain certain of our observations, right? Then you can turn around and try to model these observations as a consequence of the physical world, and this becomes a sort of mutually recursive thing, right? And the kinds of mutual recursions between mind and reality that you get with a human mind may be quite different than the ones that you get with an AGI mind, right? So yeah, the kinds of thinking that correspond to a given physical reality, of course, will depend on the physical laws. On the other hand, the kind of physical laws that you believe to hold will depend on your mind, right? And this becomes quite philosophical and in depth. But what is very clear is we are very ignorant of all these things, right? So I mean, we have changed our fundamental understanding of the universe over and over and over again with
That's for certain.
a lot of rapidity, right? I mean, quantum mechanics didn't exist at the beginning of the last century. Chaos theory was invented during the course of my career, right? I mean, we haven't yet unified gravitational theory and quantum theory. I mean, the notion of superintelligence singularity only became palpable during my lifetime. So it will be shocking if a superintelligence didn't come up with a radically different understanding of the universe that made everything we're talking about sound like the babbling of idiotic children. Right? And on the note of babbling of idiotic children, I'm going to have to go on to another meeting.
Indeed. Look, it's been great talking to you again. I look forward to doing it before the Singularity. So yeah, and also after the Singularity. But yes, have a great day, Ben.
It'll be direct mind-to-mind transmission at that point.
Yes.
And the scary thing will be the direct mind-to-mind transmission with Hugo de Garis. So you can start preparing for that.
Professor Dr. Hugo de Garis.
Professor Dr. Hugo de Garis to you. That's right. Yeah.
All right. Cool, man. Have a good one.
All right. Yeah. Thanks a lot.
Bye.